Hi there, welcome to week 4 of meteorology and intro to meteorology. And this week we're looking at map assignment number 3. And on this map assignment we're going to be concentrating on air masses and how air masses kind of move around a little bit and how that triggers weather. Some of the things that are most important at looking at air masses are the dew point temperature, the air temperature, and wind speed and direction, and how those variables shift or change to create weather. Again, we're looking at Oklahoma. Let's look at the map right now. And the dew point, the first one you see, the first page, is of air temperature. And this is actual air temperature, and that shows temperatures in the 70s in the eastern part of the state. We've got 80s in the south central and southwestern part of Oklahoma. Then you look up here to the northwest and then the panhandle. Look at that, 30s out west and 40s and 50s otherwise. Something is going on there. Something is mixing up the weather, and we need to find out what that is. The next map is we have dew point temperature. If you remember, dew point temperature is the measure of the amount of moisture in the air. Very important for producing weather. The higher the dew points, the more likely we are to see things like clouds and even precipitation. And when you see changes in dew point, you're going to see some transitional air masses moving in, and again, a mixing of those air masses will help produce precipitation. Dew points over Oklahoma in the central east are in the 50s, even a nose of 60 down in the far south. But you notice what goes on in about the central part of the state. Dew points drop off into the 30s. Remember what was over the top of that with the temperatures, where the temperatures were in the 80s, but we have dew points in the 30s. That means some very dry air. Also some very dry air moving into the panhandle across the northwestern part of Oklahoma. And some sharp transition lines between those. So something is going on there, hint, hint. As we go further down the page, we see that we have wind speed and direction again. Very similar to the map we saw last week. A little bit different, but we have a circulation system going on. Winds blowing up here from Texas, and again in from West Texas in the Texas Panhandle, and from the north in the Oklahoma Panhandle. So we have a circulation system. Again, this would be a counterclockwise circulation. That would be an area of low pressure, of course. What we want to see as far as our temperatures go, what we're looking for in the question, the first temperature is what area of the state, what we're talking about here is what portion of the state do you see the type of air mass. The first air mass is a CT. We go through the book and you get these definitions, small c, big T, continental tropical. What area of the state would you say is a continental tropical air mass? And what are the two dew point, or what is a temperature and dew points, or a series of dew points and temperatures and dew points that correspond to that air mass? The next one is a maritime tropical. The next one is a continental polar. So we have 3 air masses on that map. Again, if we go look up our dew point temperatures here, we have high dew points, low dew points. And then if we have high temperatures and low temperatures, you can see there's a transition of air masses going on across Oklahoma, and the wind speeds to show, and wind shift directions to show that those air masses are indeed colliding. So that's some of our questions we're looking at. Also in Chapter 8 there is a discussion on fronts. Describe the difference between a warm front and a dry line. We get into a dry line this week, and it is on the map, and it is showing up there. If you're having a problem finding definitions, there's several chapters that cover it in the book, and also look online. But a dry line is basically a big drop in dew points. And that's part of the answer I'll give to you right there. But tell me what a warm front is and how do those things differ. And then where is the dry line located on this map? That should be fairly obvious. If you have a problem, send me an email, and I'm happy to help you out. If the last question is now, what meteorological or weather-related variables, again, weather-related variables, help to best locate fronts and boundaries on surface maps? We're looking at the ground. Where would they, on the surface? If I'm standing in a place like Oklahoma City, what's going to happen to me over time with temperature, wind speed, direction, things like that? I don't want to know about land areas, tree lines, or roads, or some people in the past have used lakes and rivers to describe this. None of that makes any sense for what we're looking for. We want weather-related variables. What are those that help us find and define boundaries and fronts? That's it for this week. Give me a holler if you have any questions or problems. Have a good time.